So like our episode 10 is, as I mentioned, it covers like traffic engineering applications and multi-resolution modeling component in Visum software. If you're going to use Visum for following 3 topics, or it could be more, but like, main topics, this session will be useful for you. First of all, if you're going to use Visum for mesoscopic dynamic assignment, so-called simulation-based assignment in Visum, you're going to find this courses like to be useful. And if you're going to use it for intersection capacity analysis and multi-resolution modeling, you're going to find this session be useful. So here is our quick agenda for today's session. We're going to first touch on network development piece, and then we're going to briefly touch on the demand development or demand refinement piece, and also we're going to touch intersection capacity analysis component in Visum, and lastly we're going to go through the the process that you're going to need to go through to export your network to microsimulation model. First, network development. So there are like 2 big components of network objects that will need to be developed or fine-tuned, which are first geometry and then control component for each of those nodes or intersections. So first of all, geometry could be edited at the link level to take care of the shape of the links, and node level to take care of every other components at the node intersection level. For intersection control or node control, you can define that to be like unsignalized control intersections or nodes, or signalized intersections or nodes as well. So we're going to go through some of those sections step by step. So first of all, if you need to shape your network, if you need to shape your links, you do not have to have shape nodes anymore, or you don't have to. You could, but you don't need to. Because in Visum, it's going to be all taken care of by polypoints. So as you can see from the what it is shown on the left side is what you could do with the shape nodes, but again, the way that you see the screenshots that you see on the right side is how you would need to model in Visum. You could have much less polypoints, but anyways, the point being you could use polypoints instead of shaping nodes. So in order to do that, here are the steps that you'll need to follow. So first of all, you're going to find an interactive geometry edit icon as it is highlighted on the slide in the network editor window. Then you'll click on that and activate that so that you can be in that mode. And then click any link that you want to reshape. And then move your mouse cursor to a point where you want to add that polypoint and press Control and left click. Like how it is shown on the slide right here, you're going to see that that polypoint being added. So now if you want to move it, left click and hold and grab that particular polypoint and move it, reposition it to a location where it's supposed to be. All right, and then you can add as many polypoints as you need to reshape that link in a way that you want. So here's a little tips. So in most cases, when you are modeling 2-way link, you can follow along the center line of the roadways. However, if you are trying to model some sort of one-way roadways, one-way streets, such as maybe freeways or some of those boulevards or what, where it is completely separated, both directions are completely separated, and where you want to model that with the 2 separate links, both directions. Then you'll need to move your links to follow along the left edge line, so that it could still be the center line of the entire roadways, assuming that it has both directions. So we're gonna check on this as well. All right, so once you have node, you can place that node at wherever you want, but typically it works out best if you place your node at the center of all the approaches, the centroid point of all the approaches, as it is shown in the slide here. So, and also if you want to move things around, you can left click and hold on node that you want to move around to grab it, and then reposition it and let the button go, and then it's gonna reposition by itself as well. Now, if you want to go into any further details within each of those node or intersections, you can double click on any node and like it will allow you to open up the Junction Editor. All right. So Junction Editor, opens up. When Junction Editor opens up, it's going to be looking like with the screenshot that you're seeing on the slide. And it consists of various parts, I'm going to go down the list of those objects that it shows you, I'm going to talk to you about the details of it. So now, first, you can edit the details on node, which is intersection as well, and you can go there as it is shown here, and you can update the name of that intersection or node or control type of it at the node level. For the links, you can click on this link link menu here to update them. And for each of those links, you can update various attributes, such as you can update name, if you will, and enter the roadway names, or you can adjust those transportation system settings to open or close any particular transportation systems to that particular links or links as well. And you also can update the number of lanes on those links, and that number should be the the actual number of lanes that gets added, that gets maintained throughout the entire link. And also you can specify the speed of the posted speed limit on that link, and the attribute that we use for that speed data is V0 PRT. So you can update that information at the link level. So for turns, one down there is a little similar to links. You can open or close any particular transportation systems for that particular turn. And also you can define turn types, which could be used for a variety of things and afterwards. These turn types, you don't have to define that every single one of them. Initially, Visum will figure out and determine what the best turn type might be after detecting that a particular angle of those turns that it is consist of. So it's going to be your job probably to double check it and update them as necessary. So the next piece here is geometry. We're getting into a little further details into the geometry components of this. When you get to this geometry tab, it changes its view to more actual roadways, compared to how it was before. And in here, you can enter further details on each lags or lanes or lane turns or crosswalks, as far as geometry is concerned. So first of all, geometry for lags allows you to define a little further detail, such as if you have median, you can define a median in between those two directions by defining the width and length of it. And also, if you have a channelized turns happening, for mostly right turns, you can specify that length information. So all those stuff that you update will be shown on this will be visualized within this Junction Editor, and all the further details for those center islands, and then channelized turn lanes, center islands called so-called median, could be entered in a data field at the bottom here. So as you can see here, I have entered 800 feet, 8 feet wide median, which is about 800 feet long. And also for one of the other approaches, I have entered channelized turn lane with the length of a radius of 35 feet, and you're going to see it being visualized up here. All right, Junction Editors continues, and there could be some other stuff that you can do, which are lanes. So in a lot of cases, number of lanes that that you have entered for each link will be applicable to the entire sections. However, there could be some cases where you want to add those maybe acceleration lanes or turn bays or which will not carry through the entire link segment that you have, but like, there could be a case where like, that lane needs to be added like, for just a part of that link. For that, you can use this, and what you can do here is that like, you can click on that particular approach where you want to make edits, and then like you can click on this like gray box here for that particular lane that you want to make changes to. And then once you click on that, it will give you an option to add a lane on either side, to the left or to the right. If you want to add the lane to the right, you can add this plus button on the right side, and like how it is shown here, it's going to add like one additional lane to the right side. Once you do that, it will also like all the other fields are grayed out here, but it will let you update this like length of this particular lane, and you can define the length of this like such as like turn bay length or what turn bay lengths or what as well. So in this particular case, I did define this to be like 190 feet long lane, which to be added to the right side. And also, if you would like, you can define lane width as well. So lane turns allows you to define like what types of like movements could be made from each lane. So similar to how it was before in the lane section, you're going to see a lot of those like X marks, red X marks, or like blue plus button. So for those parts where like for those like connections where you see this dotted lines with the like blue plus icon, that's the like movements that you can add or further specify, while this like solid line with the X mark here is like the movement or like the turning movements that is already defined, which you could remove as well. So if you would like to remove any of those particular movement or connection, you can click on this X button to like to disconnect them. Or if you want to establish a new connection, you can click on that like particular lane and then like click on this plus button to reestablish it. All right, so I mean, you might think by now like that like it's a lot of tedious work. Yes, it is. So like we have a ways that you can like templatize those like particular set of like lag geometry settings. Especially like it might be useful, especially when you're working on downtown area where similar types of geometry settings are repeating, and like intersection after another intersections. So if you would like to do that, you can go to lags, geometry and lags, and then right-click on any particular lag where you want to use that as a template, or want to like update that like geometry setting with the template that you have already created, and that will give you these two options. First, like if you want to define that as a like template, this particular settings that you have, you can click on this define geometry template. Or if you want to like update the geometry based on like with the template that you've already created, you can like right-click on that and click on this lag template definition, and this will allow you to choose whatever the list of choose from those like the list of templates that are already being defined. All right, so now we're going to move on to the intersection control, and here's where everything starts. So within this junction editor, you're going to be, as I've told you, you can be, you can go to this node here, and then like this will take, this will allow you to open up this like node details here, and in here you're going to find a like attribute called control type, as it is like magnified here, and you can update that like to whatever control type that is adequate. So there are various types of control types that you can choose from. If you are not necessarily wanting to model the details of that control of that intersection, you can leave that as unknown. Other than that, like you can choose from various things like such as uncontrolled, two-way always stop, two-way yield, roundabouts, or signalized. So if you choose proper control types that you wish to code in, that's where things get started. So first of all, always stop and roundabout could be rather simple because like for always stop, every vehicle needs to stop, and roundabout, every vehicle needs to yield to, every vehicle which wants to enter the roundabout will need to, yield to the vehicle who are circulating. So the only other types of control that will need to define any of those like priority scheme is going to be two-way stop controlled intersections. Now, if you would like to do that, you can go ahead and go back into Junction Editor and Node and like check out how the major movements are set. As you can see on the slide now, Visum defines that particular major flow and major movement and like displays that like with the like gray arrow. So in this particular case, northbound and southbound is set to be the major movement. If you will need to update that, you can click on that major flow manually button to and that will Visum will let you define that major flow manually as well. Once you check it, you can click on one end and to the other end of the the approaches to define that manually, and that arrows that you're seeing, gray arrows, are going to be updated accordingly. So next one is like fun part. You can add further details on for the signalized intersections. So first of all, the first step is of course, you'll need to change the control type to signalized for that particular node that you want to make any updates to. Once you do that, back in the Junction Editor, you're going to see that create signal SC icon being activated, like how you can see what you're seeing on the slide. So you need to click on that to add any further detailed configurations for that particular signal timing plans. And then this will open up this new window called Create SC Signal Controller number, whatever you're going to be defining. So it will let you enter further details on various throughout various tabs. First tab that you're going to see is basis. And then in here, you can define the number, which is different than node number. So this is signal controller number. And then you can define the name of it, and you can define the cycle length, initial cycle length, and then the types of signal controller that you want to go with. So in Visum, there are various types of signal controller that you can choose from, but here are our suggestions. So first of all, if you're going to use Visum for primarily capacity analysis, which will require some types of green time to cycle length types of ratio, or if you would like to use Visum for mesoscopic simulation, we would strongly suggest to go with just a stage-based controller, which is way simpler to code in and manage within Visum. However, if you are planning to export this entire network out to microscopic simulation, such as Vissim, probably it's going to be a good idea to use ring barrier controller, so that when you export that network out to Vissim, it will be carried through to the Vissim, and you're not going to need to recode it. So next tab is nodes. This is where you can connect those signal controller and nodes, because there could be some cases where single controller are tied to multiple nodes. But a lot of the other cases, a lot of those cases, it's going to be 1-to-1 match. So a lot of times you're going to see one node in that allocated node field, but there could be more than one as well. So find a node that you want tie this to, and then you can connect. You can establish connection between nodes and signal controllers. So next tab is optimization, and this optimization, signal green time and cycle length optimization, will only work if you have chose stage-based controller. In here, you can set this to, you can allow Visum to optimize cycle length and green time, or only green time, or you can turn that off. If you choose to go with like cycle length and green time optimization option, you also will need to specify that like minimum and maximum green cycle length, so that like it can like optimize like within that boundary as well. All right. So first of all, if you would like to use, if you choose to go with stage-based controller because you're going to simply use this for either capacity analysis or mesoscopic dynamic assignment, you can go with the stage-based controller. And the first thing that you're going to need to do is like find out this like signal templates so that you can use it and you can go with the quick way rather than like coding everything from scratch. So all of you will be able to find this like the signal template files in a folder where like I have like where it is shown on the slide on a screenshot. From there you can find once you can locate that signal template right-hand traffic.net file. Simply what you'll need to do is like you can drag that file and drop it to the Visum interface itself. And then once you do that, you're going to see, it's going to, Visum's going to prompt various types of window, after that. So it will be asking you whether you want to read this additively. Yeah, of course. Like, a lot of times you want to add this like template in addition on top of the network that you currently have. So you should check this here. And then like, rest of the other settings are not really necessary for you to update, and click OK. And then it will ask you what you want to do while reading this network data in addition to your existing model. So you can go with this just the default setting and click OK. Then you're going to see that like stage template being added. So once that is added, successfully added, you're going to see that like these stage-based controller menus are all being activated, especially like this like using template icon here on the left side here as well. All right, so like what we have gone through, and after that, like you can go ahead and create like signal controller, and then like you can set this like select this signal control type to be stage-based, and then like you can configure through those like different tabs like way that we have gone through all year, and then click OK. Now, after that, you can select amongst those menus that is available within Junction Editor. You're going to be able to like should be clicking on the signal timing, and then like click on Use Stage Template button, and that will prompt like create stages from template window. Once you have that, like you can have you can enter some of those basic information, and it will like fill up those signal timing data for you from there. So let's say that like we want to create these types of stages for a given intersection here. So stage 1 is going to be a southbound through and left, and then stage 2 is going to be southbound through and northbound through, and stage 3, third stage, could be like all westbound movements, like including left and right turn. And there are some overlap phases applied for some like given right turn movements. All right, then what I'll need to do here is like set the number of stages to be 3 because we wanted to have three separate stages, and then like click through this like flip through this like templates icon, and then like try to find like the template that suits your stages well the best. And what you're going to see as well while you're flipping through is like this like Junction Editor will preview, you can preview your stages on on Junction Editor as well as you flip through. And then like you choose that. And the other thing that you may want to check out is that like because the template will not cover every single sequence that you would like to go with. That also allows you to flip, change or update those like stage sequences. So if you want like that sequence of stages to be updated, like click on that drop-down box and like scroll through it and change it to whichever is adequate. And once you're done, you can click OK, and that will add that particular signal timing there. All right, so once you have that signal timing created, you can add some more details by going to geometry and signal groups. The types of details that you can add here are yellow and all red times, and then you can turn on and off those right turn on red behaviors. If you want that those right turn vehicles to be allowed to make right turns during red, you can highlight this here, click on this red box, and it's going to be highlighted like this. Or if you want to turn that off, leave that off, you can leave them untoggled. All right, so if you have entered in some basic signal timing, and if you want Visum to update, optimize the signal timing based on the assigned volume or the other types of volume that you have allocated, then you can click on that signal optimization button within that Junction Editor, and it will update that signal timing plan for you as well. All right, second option, if you have to go all the way to Visum, you can choose to go with ring barrier controller, where more of manual entry is required. So first of all, similar to what we've done for the stage-based controllers, you're going to need to go ahead and click on new signal controller icon, and then when this create SC button window pops up, you're going to need to change the signal control type to RBC, and then click OK. Now once you do that, it will activate this menu here called Edit RBC Controller. You'll need to click on that to open up ring barrier controller user interface. Once you open up this ring barrier controller user interface, like how it is shown here, will be opening up, and you will need to enter, you will need to specify those phase numbers and signal group numbers and so forth, and you will need to enter all the detailed signal timing plans over here as well. If you already have ring barrier controller file which are generated from either Vistro or Synchro files, you can go ahead and go to File and Import, and import that particular signal timing plan that you already have as well. Okay, so once you are done defining the signal timing plans over here, you're going to need to go to again geometry and signal groups, and you'll need to tie that each of those movements to via any particular signal phasing or signal groups, like how it is shown here. So it's quite a bit of extra work that you'll need to do compared to the stage-based controller. That's why we have suggested to go with the stage-based for those cases where you don't need extreme details on the signal side. So once you're done with all that, you can use it to use a network check tool to check and see whether there's anything, any obvious mistakes that you might have made. So that could be accessed by going to calculate and network check, and there are various types of items that you can check for general settings and private transport, just general highway traffic, and then public transit down here as well. While we're here, we're going to go to the Visum interface, user interface, and see how things look like. So first of all, you're going to see that I'm going to zoom in a little bit more here. You can see some section here is two-way link, while this is one-way link here. So as I mentioned earlier from one of those slides, I would just put this link at the center line, where that this different direction link should be should be facing each other at for this two-lane link over here. And for the other one-way links, I would rather put those lay down those links along the left edge line as well here, how it is shown here. Okay, so if you wanted to add any curvatures here, first of all, you have to make sure that this permit interactive editing of geometries buttons activated within this network editor. and like make sure that like you have selected links. And if you would like to move this stuff around, you can do things like, let's say I want to make updates to this link here. You can press Control and left click to add this intermediate point. And if you want to remove them, you can do the same. Press Control, and you can see that like my mouse cursor icon has been changed to minus. In the past, it was plus. So like if you click on it with the Control pressed, you can remove them as well. You can add them, and then like you can left click and hold, drag, grab it and move it to wherever it needs to be at. So you can add multiple points to create like smooth enough curvatures, if you will. All right, let me put it back. Okay. All right, so that's how you play around with that links as well. And for nodes, let's go to one intersection over here. Let me check and see. It's going to be loading background image here. So if you would like to reposition this node, you can grab this guy by left click and hold, and that will allow you to move around. And like if you want to place your node here, you can leave it there as well. But typically I want that to be positioned at the center. So somewhere around here might be the good place. So I'm going to like left click and hold, grab it and move it back there. Let go. Okay. So as far as like the other parts of the link data is concerned, you can like select the link again and double click on that link, if you will, and you can update those information accordingly as well. If you would like to update the capacity and length is like a lot of times it's calculated automatically, or like speed levels, number lanes, you can update it here. And also like types of transport systems. Transportation system that is open to use this link could also be further defined here. If you want to add buses, you can add them. Press Control and add, left click to add them, and click OK here as well. And as Chaitan might have mentioned during his earlier sessions, if there are some discrepancies in between two links that are like opposite directions, you're going to see that like each of those like data field to be highlighted in yellow. Okay, click OK. And if you want to get into Junction Editor, you can double click on this like particular link. Node, and then that will open up this Junction Editor. Typically, the way that I use this Junction Editor is like by like having this like side by side with the with the network editor, so that you can see the background aerial views. So I'm going to left click and hold to grab this, and then like dock it to the right side of this network editor. All right. So now you're going to see that like it's here. Let me change it back to unknown so that like we can start from scratch. So let's say that like I wanted to change this to be a two-way stop controlled intersection, for example. Then you can change it to two-way stop controlled intersections, and that's when this like priority movement setting matters. Now by default it is set to be like north-south because that makes the most sense. So Visum chose that to be the default. If you would like to update that manually, you can check on this major flow manually button, and that will highlight this pink buttons on either side of the approaches. So if I want to make this like left turn or right turn movement, like from north to southeast to be the major, I'm going to click here first, and then click southeast second. Then you can see that like that major movement changes. Now like it's going to assume that like stop signs are going to be needs to be placed here instead of here, like on the like westbound approach. Now if I want to put it back, I can click this to put it back. So that's what you need to do. And if you would like to go ahead and like go through some of these things, here you can update name of this intersection, links. Any links that is associated with this particular node could be searched up here. You can find the link types, like translation systems that is open for each of those links associated with this, like this particular node. Number of lanes for that particular node that is like that you have selected, and like speed level. All right, and then like for each of those turns, you can like see the list of turns that are open for this particular node. If you would like to see all the turns that is available, you can like right click here and like select the show also closed turns, and you can see some of the other turns that are like not open but available as well. So you can see here, like the thesis set in here is like it says ... which is like which shows that like nothing's selected. In other words, it's closed. All right, and then like let me put it back to only selected ones, and you can scroll through it and see like visualize what types of turns are open here as well. All right, so here's the geometry. Like here's the lags. Like here are like further detailed information here: lags, lanes, lane turns, and crosswalks. So first of all, lags allows you to define this like medians, as I've mentioned here. So if I update this like from 8 feet to 20 feet, you can see that like this gets widened. You're going to get a wider median. But this could be defined based on like whatever stuff like that you can measure here. And that's when you can have this like network editor tool to be used quite handy. You can go back to this network editor and then like click on this ruler icon to measure like the width of it. So if I want to measure it here, okay, I can measure it here, say like 8 feet. Then what you can do here is define 8 feet here as well. All right, and the other part is like that channelized turn lanes. So if you can measure like sort of a radius of these turns, so it could be like somewhere around like 35 or something, then you can enter 35. So if you have like much bigger like radius, radii that you need to enter, you can enter them, and you can see that like expanding like here as well. All right. For each lanes, you can go ahead and like update them. And in this particular case, I don't necessarily have a lag on the like this like east and west side, so I cannot enter this like left turn bay here. But for right turn bay here, what you can do here as well is first click on this particular approach to where you want to make updates. Let me go ahead and like remove this so that we can view it a little better. Click on this like particular lag approach where you want to make updates. And then like if you would like to add lanes to the right, you can click on this button, plus button here, and it's going to add more lanes to the right, which is more like temporary lanes. And if you want to remove them, go ahead and click on this X mark here. So if you want to, after you enter that, you have to specify the length of that like lane, and that could be done here as well, like where it says length. All the other lanes which came with just the link doesn't have to have a like length defined, because that is equal to the length the length of the link. But for this temporary lanes, you're going to have like this length defined. Now lane turns allows you to specify those connections. So if you want this lane to be like shared, you can click on this plus button. And now this lane is going to be used for both like right turn and through movements. And if you want to update any of them, you can do in that way. You can close this and add them. And like you can not only view that like the connection via this like this solid and dashed lines, but also this arrows here as well. All right. And if you have to add crosswalk at any particular approach, you can go ahead and do that as well. Like the way that you can do that is similar to the other things. You can if you need to add this crosswalk along across this like westbound approach, then you can go ahead and click on this plus button to add them. Or if you need to remove them, you can click on this X mark here. And this allows you to enter the width, and for maybe HCM analysis and all other, you can enter pedestrian volumes, hourly pedestrian volumes in there as well. All right, so now let's say that like we want to go with maybe I'll just delete signal group controller here. Let's say like we want to add like, signal controller details here. So first of all, what I'll need to do is go ahead and go to node and change this to signalized. And then you can see that like this create SC is activated. Okay. Now, like the other thing that we'll need to do is we need to find that like, the template files on like, that stages, all the stages. And I think those files are probably here. Under data, there are like signal templates, and you can locate this like, signal templates, a right-handed traffic.net file. You can simply drag and drop, and it'll ask me to save it. Yeah, let me save it. And then like it will ask you a couple of things, like do you want to read this additively, that type of stuff. You can click OK. Once you click OK, you're gonna see like, whatever, all the other settings where you could go ahead and like click OK as well. I mean, and just, except for the case where you want to specify any of those like, attributes to be done, imported a little differently. Now, once you have that and create this and select the stage-based and click OK, and then you're gonna see that this template icon is like, being activated. What you can do is like click on the stage template, and then as we have discussed, like I'm gonna need 3 stages, one for this like, southbound movement, southbound through and left, and north and southbound throughs and westbounds. So I'm gonna need 3 stages, and I'm gonna go with the template which like splits up those like, different lanes here. And this will, as I've mentioned, this will show you, I mean, you can preview how the signal stages are gonna be looking like. So in this particular case, I don't have this left turn to go first. So I wanted to rearrange this to be like 2, 1, and 3, right? So left turn goes first, southbound, and then like north and southbound goes together, and westbound. So once you found the right combination, you can click OK. Then that will like, set everything to be, permanent here. Okay. And then after that, as I've mentioned, you can go back to geometry and signal groups. Or stages in this particular, signal groups in this particular case. And I don't see those attributes here. So I'm going to go ahead and add them, amber and all red. And you can define those amber and all red here as well on top of that. And also for those movements where like right turn red is allowed, you can like, select this, toggle this so that you can like, activate this turn red or turn off as well. All right, so if you have this and if you have assignment results, you can like, do optimization. Oh, probably I didn't set this to be allowing this optimization. So let me go ahead and like, turn this on. And then, it'll update like based on the whatever volume that you might have. All right. So this is how you can enter those like signal timings and so forth. Now, the other piece was calculate and network check. You can do this network check here, like, by going to calculate and network check, and you can do check and see whether there are like any isolated nodes and any turns that doesn't make sense, or like, network consistency, links with no successing links, or capacity of 0, like, usability or viability of those like network components for capacity analysis here, or A&M export, which is like, for the this multi-resolution modeling as well. You can run this, and it'll go through the like, whatever checks that like, that you have selected, and it will run through that, and it will give you like, whatever messages that it came up with. So probably I should have not choose bike because I don't necessarily have bike components like coded into this. Yeah, it's going to go through this, and it's going to take a little longer, I guess, than I have anticipated. So there are like a lot of messages. Most of those are byte because I didn't enter any details on bytes. But like there could be some other components, like you can click on each of those messages and see which one's relevant for you. Right, let me go back to this lightning presentation. All right, the next part that we're going to go through is demand development or adjustments. So there could be some cases where you do have base year turn volumes and base year assigned volumes and future year volumes, and you'll need to develop future year turn volumes and link volumes. You can go ahead and use the NCHRP 255 procedures, and that is built into Visum as well. The way that you can use that is like you can go to procedures and add new procedure under like miscellaneous and NCHRP 255 and click OK. And if you double click on that like NCHRP 255, you can like it will prompt the further detailed or configuration. And in there you can select desired procedure type and target attributes and like click OK. And when you run that procedure again, it will add those like adjusted link volumes and turn volumes and update that like whatever attribute that you have allocated here down here as well as an output data. And the other thing that you can do also is like OD estimation, OD matrix estimation. Once you have like a network model and demand matrices and assignment result along with the count data, you can run you can use built-in matrix estimation functionalities in Visum. So similar to NCHRP 255, you can add this to new procedure matrix demand matrix correction under matrices and click OK. And you're going to need to choose from either like T-flow fuzzy, least square method, or least square dynamic ODME method. And you can go into further details and with the further configurations. Now, we also had a session covering this ODME in Visum entirely, for 20 minutes. So if you want to know more about ODME in Visum, you can go ahead and use this. Use the link that is shown on the slide now. Now, the other portion is like intersection capacity analysis. So first of all, you can have general settings on intersection capacity analysis by going to calculate and general procedure settings. If you go to node impedance, this will ask you what where you should pull the data, volume data or turn count data from. And then also you'll need to make sure that like standard impedance calculation method is set to be node impedance calculation ICA, so that it will do proper capacity analysis. So for signalized intersections, there are various types of methodologies you can choose from, including HCM, like recent versions of HCM, 6th edition, 2010, and 2000, as well as like circular 212 and ICU methodologies. And also you will need to define that ideal saturation flow rates and so on and so forth from here as well. All right, same thing applies for the other types of controls. Two-way stops and always stops, like you can choose from either 6th edition, 2010, or 2000 version of HCM. Same for roundabout, 6th edition, 2010, or like if you would like to go with the Kimber method, you can choose to go with that as well. Once you choose this, all those intersections with this particular control type will use that particular methodology to do any of those capacity analysis. So once you have all this detail coded in, which we covered in the network development piece, you can go ahead and click on this LOS button here, and it will run capacity analysis, and then it will generate this Excel format report for you as well. And then we're going to get to that in a bit. And also there are a multi-resolution modeling piece. If you would like to connect this entire network to microscopic simulation, these are the steps that you'll need to follow. Okay, so there is a middle piece in between that connects Visum and Vissim, which we call abstract network model. So that is an XML-based file, which allows that any types of network data exchange to be happening in a rather open format. So first of all, if you're ready to go with whatever network that you have coded to be exported to Visum or A&M, you can go to in Visum, you can go to File, Export, and like you can click on Vissim A&M option. All right, and then that's going to open up this A&M export window where you'll need to define the path for the network file and the demand file. Also, like we also call that as a routes file. And then also like you'll need to define further like details such as like vehicle categories or vehicle like which defines the vehicle characteristics. That is going to be imported to Visum. And then like and also like its relationship relationship in between link type and then driving behaviors that's going to be reflected or used in microscopic simulation model as well. So what you're going to need to choose is like either that's urban or freeway or pedestrian path walk, paths and so on and so forth. All right. It also like if you have proper set of like public transit information coded into Visum, it also like brings it in with the proper schedules and stop locations and transit lines as well. Signal timing, simulation time periods here defines you like out of whatever like model simulation model assignment that you've done, what part of the assignment that you want to crop out and like push out to Visum. So what is shown on the slide here is like 3 p.m. to 7 p.m. So what I'm extracting from Visum and pushing out to Visum is like the result from 3 p.m. to 7 p.m. in this particular case. And also you can further define those signal control details and some other objects as well as needed. Now once you go into Vissim, you can go to File and Import and A&M. And it will ask you to specify where that A&M file is and where the demand file A&M routes file is, and whether you want to bring it in the demand data as static routing or dynamic assignment as well. And also you'll need to define where that Visum input file should be saved at. All right, so also we have covered this the data import component in PTV Visum. The PTV Visum component. Way further details of it could be found in our getting to know PTV Visum recordings. So please feel free to use this URL to get to that and and learn more about it as well. Now I'm going to go back to Visum, and then. Not the right one. And show you how this level service capacity calculation works. So first of all, you can go to calculate and general procedure settings, and then node impedances. And this is where you can define those where the data could be pulled out from component. And if you have multiple hours, a multi-hour assignments, probably you'll need to scale down the volume level because all the HCMs done at the hourly level, HCM calculations, capacity calculations done at the hourly level. And node impedance calculation to be ICA here. And as I told you, as we have gone through, you can change further details for different control types. And once you make any of those changes here, it will be applied to all the other all the intersections with the set that given control type. So in here I have some volumes here, and then signal controls and also lane geometries. I can go ahead and click on this Ica Report window, and then it will give you some things like this HCM result here as well. Also, what you also can get here is you also can get this level service and delay information as a part of node as well. So if you want to use this to display that result in here, like how it is shown here, red to green types of scale, you can go ahead and do that as well. All right. So now let's say I want to push this network out to Vissim. Now, I have coded in further details on geometries and all that along this I4 corridor out of this Olympus model, and I want to push out that that part of the network. Then there are various ways that you can do. Let me close out this Junction Editor for now, and also I'll turn off this aerial view. You can go ahead and click on this multi-select mode, and you can define your own polygon here, or you can drag and whatever, choose with the rectangular shape area. However, I have predefined this territories, this polygon, which only covers this like an I4 corridor. So I'm going to go ahead and click on this mark objects in territory. So if I select this, it's going to only select the all these objects within this boundaries here. So once I have this, I can go ahead and calculate, and then let me make sure that I have assignment result here. So I have some assigned volume. Okay, cool. Now I can go ahead and click on this calculate and sub network generator, and I'm going to define this as whatever sub area network 2 can call, and I want to bring in all the vehicle classes, all the demand segments. And I want things to cut off for public transit. Okay. And then when you're done, you can create click OK. And once it's done, I can go ahead and reopen this to go more like live. All right, this network came in, and those coordinate zones are all being created with appropriate connectors as well. So I'll need to run assignment once again, because it doesn't necessarily bring in all this assignment result. It just brings everything in the context in the form of trip tables. I'm going to run this real quick, and it's going to be short. It's fine. And then what you can do here is that you can go to File, and then Export A&M. Okay, and then you can define network data here and route data here, the demand data here, and you can further define those vehicle characteristics, such as some obvious ones, such as bike needs to be bike, of course, and then walk needs to be pedestrian, or so and so forth. All the other stuff looks fine. And driving behavior, if you have any particular link type set up for freeways, you can change this to rural, or you can leave everything to be urban as well. We don't necessarily have further details on PUT, public transit. So I'm going to go to further settings. In here, you can define installation intervals. And I know that this starts from 3 to 7. And then you can click OK. Oops, I didn't define this thing. So I can define this to be whatever the file name is supposed to be. And it's going to generate some file called .anm for network data, and .anm routes for demand data. So in Vissim, what you're going to see here is that can go ahead and import an ANM, and you'll need to tag it to this ANM file here that is being generated from your another sub area or entire area. If depends on what you want. I can define it here. If you want to convert this into a dynamic assignment network, you can select it here, either static routing or dynamic assignment, and then input file here. And when you're done, you can click import. Just for the sake of time, I'm gonna just load whatever came in here. So this is based on the whatever network that I showed you. Of course, there are some parts where it needs to be further fine-tuned, but it brings in all those curvatures and stuff like that, and number lanes and control signals fairly pretty nicely. So I'm going to go ahead and run this and see how this looks like. You can see the the signal cycle through. So let me turn off the visualization, and let me turn off the background image because it's kind of quite busy. So once I start running it, let me go to the edge of the network. You're going to see those vehicles loading into the network based on the whatever assignment result that you have, and you're going to see cycle signal timing cycling through like this. What I've entered here are all fixed times, so it may well look it's running inefficient, but that's why. So you can start from here and do any further stuff in Vissim itself.